Hello everyone, welcome back. Today we will be discussing the post-contest analysis of Codeforces Round 1046, Division 2. In this session, we will be solving the first 4 problems and break them down and step by step. So without further ado, let's dive into the very first problem of this contest, and the problem name is In the Dream. Okay, let me read the problem statement first. Two football teams, ROI team and KDOI team, are about to have a football match. A football match consists of two halves, the first half and second half. At the beginning of the match, both teams have a score of 0. As a fan of both teams, Aquawave knows that the two teams have a similar level, so neither team will score 3 consecutive goals in the same half. Okay, so Aquawave had a dream before the match. The score at the first half is A ratio B, and the score of the second half is C ratio D. We have to determine whether Aquawave dream can be true according to the above information. Okay, and we are given A, B, C, D's are the values, and yeah. So let's understand the problem statement first, and let me copy this and paste it here. And these four values are A, B, C, D. Okay, so we will handle the two cases separately, first half and the second half. Okay, so first half A is equals to 3 and B is equals to 1. Now we want Aquawave dreams come true. In order to dream come true, we want neither team will score 3 consecutive goals in the same half. Okay, so let's consider the very first half. Okay, so we will assign the values such that neither of the team will score three consecutively goals. So we can do something like this: B A. In this case, A scores 3 consecutively or 3 times. So this configuration is wrong. Okay, so this configuration is correct, I guess. Yeah, A is neither occurring 3 times or B is neither occurring 3 times. So this configuration is good for the first half. Okay, so we want this type of configuration to dream come true, and same for the second half. For the second half, we can say 13 comma 5, and this is the final score, right? So we have to subtract C minus comma A, because at the first half the team A score has a 3, and the final stage is 13. So we will do C minus comma A is equals to 13. 13 minus 3 is 10. C value is 10. C value is 10. And for the second half, D value is 4. D value is 4. Okay. So we will again assign each goal team such that it can neither be consecutive 3 times. Okay, so if I will represent this type of thing, CCD, CCD, CCD. So 2, 4, 6, 8 and 10. Yes, and I guess this configuration is good to go. Yeah, and as we can see, the answer for this test case is yes, and this is 6. 3 plus 3 is 6. Yeah, so answer for this test case is 3. So let's move to the solution, how we can assign the values such that the Aquawave dream can be true. Okay, so as we can see in this problem statement, we can assign at max 2x plus 1 values. 2x plus 1. Yeah, let's see how. If value of C comma D is 2 comma 5. Okay, so I will represent D as a maximum element and 2 is a minimum element. Okay, so 2 is a minimum element, 5 is a maximum element. Okay, so we have to assign the values. Yeah, we will have to assign the values. So first I will try to represent as D comma D, then C, D comma D, then C. Okay, then we have left with D. But at max we can do this stuff, right? Okay, and C value is equals to 3. But we have a D is equals to 5 and C is equals to 2. Yeah, we can assign D is equals to 6. As we can see, D is equals to 6. Yeah, so C value is 2. So we can do something like this. C is equals to 2 and 2 into 2 is 4. 4 plus 2 is 6. Like C covers 2 behind this. This C cover 2 behind 2 and this C cover 2 behind. So each C will cover 2 D's, right? So 2 into 2, 4. And at max C can handle this stuff also. 2 into C plus 2. 2 into C plus 2 is 2 into 2, 4 plus 2 is 6. Okay. So as we can see now, the C can only handle 6 configuration. If it is, if D is less than 6, then it will be satisfied. Otherwise, the condition is not satisfied. For example, now C and D value is, let's say C and D value is, C value is equals to 2 and D value is 7. Okay. So how we can assign it? DD, C, DD, C, DD. Okay. So at max we can do 6. But we if we count the number of D is equals to 6. We have to assign the remaining D part, right? Either we can assign to the left or either we can assign to the right. If we will assign to the right, it will occur as a 3 consecutive D's, right? This stuff. Or if we assign D to the left part, this D has to be 3. Okay, so we will not do something like this. So as we can see, we can assign only C in 2 into C plus 2. Okay, so yeah, 2 into C plus 2. And we will also this condition is also has been reversed, like C is equals to 7 and D is equals to 2. So we will also do the same thing, CCD, CCD, CCD. Yeah. And C is equals to 6 and we want C 6, but we have a 7, right? So this condition is not satisfied. If I will C is equals to 5, then this condition is satisfied. So I hope the solution is clear to everyone. So I will summarize this. I will quickly summarize this. First, I will try to find minimum between A comma B and maximum comma A comma B. Okay, so we want max comma A comma B is less than or equal to 2 comma minimum of A. Let's say minimum of A comma B is equals to X and maximum of this is Y, and we want 2 into Y plus 2 plus 2. Yeah, and this is represented as Y. We want this, and this is for the first half, and also we can do same for the second half also. First we have to subtract C minus A, because we have given in the problem statement C and D is the final state, like C and D is the score of the KDI team at the end of the second half, right? So we have to minus the A and B at the C comma D. So we will minus C comma A and D minus B, and we will do the same thing. Minimum of C comma B, C comma D is equals to X, and maximum of C comma D is equals to Y. If it is less than of 2 into X plus 2, then we will good to go. Otherwise the condition is not satisfied. So I hope the problem statement and solution is clear to everyone. So let's move to the how we can code it. Okay, so let me show you my implementation. Just give me a second. Yeah. So as I have mentioned, 2 into A plus 2, Y into 2, B plus 2. Okay. So this is the same thing. B minus X is greater than 0. I just quickly reversed it, right? Okay. So yeah, B minus X. Let's say B is equals to I will take an example. A is equals to B and B is equals to 7 and A is equals to 2. Okay. So A value X value is 2 into 2 plus 4, like 2 into 2 4, 4 plus 2 is 6. So B has to less than or equal to 6, but B minus 6 is greater than or equal to 0. 7 minus 6 is greater than or equal to 0. Yes, the condition is not satisfied. Same for the yth part, right? Okay, so I will subtract A and B from C minus D, and we will do the same thing which we have done earlier. Okay, so I hope the solution is clear to everyone. So let's move to the second problem of this contest, and the problem name is like the bit set. Let me read the problem statement first. And yeah, you are given a binary string S of length n as well as integer k. Aquaway wants to construct a permutation P of length n so that each I is less than or equal to n, where Si is equals to 1. The following condition is holds, and the condition is each interval L to R whose length is at least k. It covers I, then the maximum element among PL to PR is not PI. Note that there is no such constraints on index. PI is 0. Okay. So let's understand the problem statement and then we will move to the solution. Let me just copy this and paste it here. Yeah, these are the two test cases, and yeah, and these are answer is yes, yes, and yes. No. Okay. So yeah. So for we are given an value n comma k. For each k sub arrays whose length is at least k, we want pi where si is equals to 1, where si is equals to 1, then we want L to R maximum element is not equal to pi. Maximum element among L to R is not ith element. For example, as we can see in this test case, P is equals to 1432. Yeah, P is equals to 1432 and SI is equals to 1. SI is 0. Uh, S is 0 0 1 0. Okay, so in this region we are given K is equals to 3. Okay, K is equals to 3. So we want k is equals to 3. Okay, so let's say the first k sub arrays whose length is at least k is this sub array. Okay, so our si is equals to 1. As we can see, si is equals to 1. So if we want L to R maximum element is not equal to ith element. Ith element is 3 and maximum element of these three sub arrays is 4. Okay, which is not equal to ith element, right? So yeah, uh, another array for this at least length k is equals to 3 is this array. Yeah, si is equals to 1, si value is equals to 3. Okay, so maximum element of these three elements is 4, so which is not equal to this element, right? So yeah, we want at least 3. So another sub arrays whose length is greater than 4 or equal to 4 is only this array, and si is again 3, and the maximum element among all these 4 sub arrays is 4, which is not equal to 3. So yeah, this array condition is satisfied, right? This permutation is satisfied. So we have, if the condition is satisfied, we have to print an array of permutations. We have to print permutation, otherwise we will print no. Okay, so how we can solve this problem? I hope the problem statement is clear to everyone. Let's move to the solution, how we can solve this problem. Okay, let's consider this test case. N is equals to let's say 6 and k value is equals to 3. Okay, so we have 1 comma 1 comma 1 0 1 comma 1. We will find this, like we have to find the permutation, right? So I will assign no matter how minimum values I can assign. Let's say 1 2 3 and 4 5 6. Okay, so if we will find the three consecutive elements of 1, okay, if we will find k consecutive ones, at least k consecutive ones, right? These are the k consecutive ones. So the answer of this test case is no. Let's see how. Okay, so if k is equals to 3 and we will find three consecutive ones, the answer is no, because if I will assign this value is equals to 3, then the maximum of elements is 3, and we will find 3 comma 3 is which is not equal to, which will not satisfy the condition. Let me take another test case to understand it better. And 1 comma 0 1 comma 1 0 1 comma 1 0, and k is equals to 2. Okay, so as we can see, these are the this is a k value is equals to 2. So the first two elements, let's assign some value 1 comma 4. So what is the maximum of this subarray is 4, and we want si is equals to where si is equals to 1, we want L to R maximum element is not equal to ith element. So ith element is equals to 4 and the maximum element is also equal to 4. So it will be not satisfy this condition. So let's try another case. We will assign the value of sub array is 4. Yeah. So let's assign 5 comma 6. 5 comma no 5 comma 6 नहीं, 7 comma 3, 7 comma 2. Okay, so as we can see, si is equals to 1 and the ith element is 7, and what is the maximum between this range is, what is the maximum between this range is 7 comma 2 is 7. So we want li, we want pi is not equal to maximum element between pl to pr. So if we will find k consecutive ones, the answer is no. If we will find k consecutive ones, the answer is no. But if we somehow find at least one between k consecutive ones, for example, uh, yeah, 1 1 0 1 1 1 1 0 1 1 0. Okay, so let's suppose that k value is equals to 3. Let's suppose that k value is equals to 3. So in each sub arrays, at least one is equals to 0. For this sub arrays, at least 0. For this sub array is 0. So we can assign the values 0 to be the maximum element. Okay, so let's say I will assign 1 comma 2 and this part to be 3 3 6 and 3 6 9. Yeah, I can assign this value as 9, 3 comma 4 8, and I will assign 4 comma, okay, 3 comma 4 8 5 comma 6 7, right? Okay, so as we can see where the length of at least k, this is the part of 3. So what is the maximum value of this is 9, and ith element this is 1. So ith element is 2, which is not equal to the maximum element. Ith element is 1, which is 1, and maximum element between the L to R is 9. So 1 is not equal to 9. So this condition is not satisfied. So let's move to the another subarray 293, and this length is at least k. Okay, so we have a 0 is equals to 9 and it is not equal to the pi element. So I hope the problem statement and the solution is clear to everyone. Basically, we have to find at least one zero of each subarray whose length at least k. If we will find the one zero, then the answer is yes. Otherwise, answer is no. Okay. So we will try to assign the 0 as the maximum elements and all the rest of the element is minimum value. Okay. So I will implemented a sliding window technique to solve this problem. So yeah, first I will move from 0 to k, and I will increment my count value is uh, 1. Okay, if we will find 0, for example, let's say 1 comma 1 0 1 comma 1 comma 1. Okay, so k value is equals to 3. So if I will first iterate 0 to k, uh, 0 to k, 0 to k, and then k12. Okay, so if I will find at least one 0 from 0 to k, and then the answer may be possible, otherwise answer is not possible. Count value is less than or equal to 0, then the answer is no. Then I will iterate from k to n. If I will find my 0, then I will increment count, and basically this is a sliding window technique where you can subtract 1 by 1 as I minus k is 0, then I will decrement my count. If I will find count value is less than or equal to 0, then I will print simply as no. Then okay, so I will create my answer. If I will find my SI is equals to be 0, then I will assign the maximum possible answer to the vector. Answer of I is equals to a minus minus. Okay, so the rest of part is also clear, and yeah, so I hope the solution is clear to everyone. So yeah, let's move to the third problem, against the difference. Let me read the problem statement first. We define that block is an array where all elements in it are equal to the length of array. For example, you can read this example. An array is called neat. It can be obtained by the concatenation of an arbitrary number of blocks. Note that an empty array is always neat. Okay, you are given an array A consisting of n integer. Find the length of its longest neat subsequence. Okay, so let me just copy this test case and pasted it here to understand it better. Okay, first of all, let's understand what is a block mean. Block mean where the length of the array is equal to the element of the arrays. For example, 3 comma 3 comma 3. Length is 3. Length is 3, and all element is 3. All element is 3. So 3 is 3 equal, then it will satisfy this condition. For example, 2 comma 2, length is 2, and array all elements is equal to 2. Okay, this condition is also satisfied. 4 comma 4 comma 4, this condition is also satisfied, and this condition is not satisfied. 4 comma 3 comma 3, length is equals to 4, and the array element is also not equal to 4. Okay, so yeah, I hope this is clear to everyone. Block. Now the subsequence is called neat if we can find the subsequences of blocks is maximum possible. Okay, so yeah, we have to find the subsequences of blocks to maximize the longest length. For example, this part and this part is make a block, right? So the length of block is 3, and also this block can be made, right? 1 comma 1, and the 1 plus 1. Answer for this test case is 5. Or we can make something like this. Or we can make something like this. 2 comma 2, 2 comma 2, and 1 comma 1. So what is the length of this array? 2 plus 1 is 4. But we want maximum possible. What is the maximum between 4 comma 4 5 is which is equals to 5. So we have to assign the value. So we have to find the maximum value of this array we can take. So I hope the problem statement is clear to everyone. So let's see how we can approach this problem. And this problem is very, very important for the interviewer's perspective. And it is very much amazing because in this problem we will use the two concepts. First concept is dynamic programming, and second is we use binary search in this algorithm. Okay, so let's see how we can implement this algorithm. In order to solve this problem, first we have to determine the states of DP. In this problem, states of DP, we can determine something like this. So this is the test case. Let's say I am standing right here. Let's say I'm standing right over here. Okay, so I want a block of 3. So it means I need a length of 3 also, which will contain my 3 elements. All the elements is equals to 3. I'm right. I'm standing over there 3. So I want my next 2 elements to be the part of this block. Okay. So if I'm standing right here, I want I plus 1 to nth element. We have to find the 2 occurrences of 3, right? Let's suppose that uh, let's suppose that I'm standing right here. Okay. So what is the element? 5. I need my 5 elements which is equals to 5, right? So this can make a block, right? Okay. So I am standing right over here. So I have to find the uh, 5 ahead of this ith element. Okay. So I have to find I plus 1 till n 4 elements which is equals to my 5. Okay. So yeah. And my states of dp represents, let's dp of I represents the maximum element, the maximum block we can make the maximum answer we can make if I will take the ith block, if I will take the ith block. Okay. So now my what is my transition? Dp of I is equals to dp of I plus 1. Okay, it means the answer will still remain the same, or we can make dp of I plus 1 plus v of I. v of I am adding, this condition is only true when if I am standing right over here, I need 5 elements. One is present over there, and I need to find the next 4 occurrences of 5. Okay, so let's take another example. If I'm standing right over here, I need my occurrences of 2 from I plus 1 till n. I plus 1 till n. Okay, I need only one occurrences because 2 occurs only 2 times, and one of the occurrence is present right over here. So I have to find the remaining one occurrences from I plus 1 till n. Okay, so let's say if I am standing right over here and my element is 3, so I have to find I plus 1 till n, 2 occurrences of 3. Okay, because I have to find the we have to make the block, right? Okay, so yeah, this is the states of dp, this is the transition. And what is the answer? We can make dp of n, maximum of dp of I plus 1, or dp, oh sorry, answer we can make, we have to like, we have dp of I plus 1, and dp of I plus 1 plus v of I, and answer is stored in dp of 0 because we will find the maximum element at the 0th point. Okay, so in this case I am iterating from n minus 1 till 0, from backwards. Okay, So let me summarize my solution, what I am thinking, and I will show you my dry run of this code because it is very important problem. Yeah. So if I am taking this test cases, I have simply said that if I want to take this element, if I want to take this element, this block. So what is the occurrences of 3 till now? Only one. Okay. Only one. So I have to find another two occurrences of 3 from I plus 1 till nth element. Okay. So let's say this is the one occurrences, or I will mark as 3. This is the second occurrences. So it means at this point I can make this answer. Okay. At max I can this make it as answer. So yeah. So we can make this answer to, what is the answer we can make is 3. That's why I am adding plus v of I. So let me dry run the test cases, all the test cases, how we can make this. Okay, so let's dry run our solution, whole solution, and I have make vector of vector which will store my element comma where it is present. Like for example, 2 is present at 0th index and the 4th index. 3 is present at 1st, 2nd and 5th index. Okay, so this is the vector of vector, and I will create a dp vector which will initialize with zeros, and dp of all the arrays remaining are 0. So I will try to make my answer this as 1. Okay, so 7, I need 6 occurrences of 7 at the from I plus 1 till nth index. Okay, so currently my I is 9, so I want 10 till nth index to be the part of 6 occurrences of 7, and we can see that our array is empty and our array is has not valued. So what is the maximum of I plus 1? 0 comma 0, and answer for this is 0. Okay, so next pointer is 8. Next pointer is 8, and 8 is present, 1 is present at 8th index. Okay, so yeah, and I need I plus 1, like 1 is occurring only one times, so I can take this element, right? I can take this element. 1 minus 0, 1 minus 1 is 0, so I need 0 occurrences from 9 till nth. Okay, n is basically 9, n is 9. Okay, I will type this, n is 9, n is equals to 9. Okay, so yes, I need my 0 occurrences of 1 from 9 to 9, and I will find a 0 occurrences of 9 to 9. So yeah, I can take this as answer as 1. Okay, so I will come from the 7th point, 7th, and my element is 1. So I need 1 minus 1, 0, 0 occurrences from 8 till 9th index. As we can see in this problem, 7 is present is right here, but we have find 8 value. We can find greater than or equal to, but not less than. Like for example, if 3 is present right here, so if 3 is present right here, I need at least 3, at least 2 occurrences from I plus 1 till nth. I plus 1 till nth. Okay, there are more occurrences of 3, but it doesn't matter because we need only 2 occurrences for the for this block also. Okay, so yeah, answer for this test case is also 1. Okay, 1 plus 1 is 2, 1 plus 1 is 2. So now coming from the 6th index, I need 5. I need a block of 5. So I need 4 occurrences from 7 till nth. But as we can see, we have only 3 elements, 1, 1, 7, and there is no single element present in between, which is equals to 5. And so we will take only the maximum of previous one and the current one. So answer is again 2. So 3. can I assign three, like we need two occurrences from 6 till 9. We will find no value, so we again answer is 2. And for this part I need two occurrences from 5 till 9. Oh sorry, one occurrence is from 5 to 9, so we will not find, again answer 2. So yeah, 3. For this part we can make for this part we can make 3. Answer is 3. Now for coming part, this also is 3, and I will move to the this index. Now here is a test case which we have to consider it. Okay, so now our answer is 3, but I need my value 3. So I need two occurrences from 2 to 9. As we can see, we will encounter this and this, and they are the two occurrences from the 3. And 3 is 1, 3 is 1, and we have a two occurrences which is greater than or equal to 1. So we will take as dp of I plus 1, maximum of dp of I comma plus of v of I. So it answer is 5, and this also is 5. Okay, so what is the maximum answer we can make is 5. Okay, dp of 0, as I have told you, dp of 0. Okay, let me show you my implementation, how I implemented this problem. Okay, so I will store a vector of vector position which will store my element comma index, and I will iterate it from backwards n minus 1 till greater than or equal to 0, or I minus minus, and I will initialize my dp vector to be the 0. Okay, now my value is v of I, and I have to find the position of this value where it will be light. For example, in this case scenario, let's say I am right here. Okay, so my element is 3, and I have to check whether the whether 3 minus 1 is 2. 3 minus 1 is 2. So I have to check whether the two occurrences of 3 is present or no from till 2 index till 9. I plus 1 till nth index, two occurrences of 3 is present or no, not. Okay, so this will give me the lower bound. Okay, this will give me the index. If index plus value is less than of position of value dot size, basically what does it mean? 1 is less than, lower bound give you a 1, and 1 is less than of this size, then we will take it as dp of I plus 1 and position of v of index plus 1, and this is the value basically, and we have to add that value. If it is not that condition, we will take as dp of I is equal to dp of I plus 1, and we will print our answer is dp of 0. So I hope the problem statement and the solution is clear to everyone. So if the solution is not clear, you can comment it out, and I'm willing to answer it. Okay, so that's the whole crux of this problem.